Today we're going to begin our unit on collecting data, sampling techniques, and methods of sharing our results. So what we're going to do first is we're going to talk about how do we actually collect our data that we use whenever we want to find averages and medians and everything. So reliable ways of finding data. We could have one or two methods. The first method is called an experiment. And in that experiment, the researcher is actually giving a treatment to one group of individuals and then collecting data based on their response to that treatment. They're actually manipulating something within that study. So, for example, where it says a researcher adds acetone to gasoline to measure its effect on fuel efficiency, the researcher is actually participating in this study because they are adding the acetone to the gasoline. So they are actually affecting the way the gasoline may be performing. Okay, so in an experiment, the researcher is actually manipulating something, it's changing something. In an observational study, the researcher is simply observing, watching, recording what they see. They measure variables that might be changing, but they're not controlling the way people react to something or the way something performs. All they're doing is simply sitting back, watching what happens, and recording the way things occur. So an example of an observational study would be where a researcher wants to find out if poor nutrition affects eyesight, but it would be unethical to deliberately subject some individuals to poor nutrition. Okay, so what they're talking about by saying it's unethical, it would be wrong to make some people just flat starve just to do a study. So what this researcher would do is an observational study where they would observe people's eating habits and maybe record the results from a visit to an eye doctor of people who have plenty of nutrients, good balanced diet, and then they might record the results of a vision test for people who maybe don't eat as well or not receiving as many nutrients as they need. They're not actively changing something. I mean, for example, they're not starving someone, but they do recognize that there are two different groups. They're just not actively changing something in that group. Okay? Now, another type of study that you could have is called a randomized comparative experiment. And in that kind of study, the individuals are assigned to a control group or the treatment group at random in order to minimize bias. So in this study, you might have the researcher would have one big study group that they're choosing from. For example, we could choose the entire junior class. That would be our group that we're studying. Now, if I wanted to see how M&Ms affect the group's performance on a test, I could give M&Ms to half of the class. That would be my treatment group. And I could leave the other half of the class alone. They don't get M&Ms. That would be my control group. The control group is where you just kind of... That's where you just kind of that's your baseline group. That's your normal group, for lack of another term. That's how students would normally perform on a test. That's your control group. The treatment group is who gets the M&Ms or who gets the special study. So in a randomized controlled experiment, you randomly choose some kids to get the treatment, and then some you leave them alone. Okay, so let's talk about a few situations and talk about whether or not it's an experiment or an observational study. All right, for letter A, a researcher wants to know if a soil additive makes a fern grow more quickly. He grows one specimen in treated soil and one in untreated soil. So we've got two ferns. One of them, he is actually adding something to the soil to see if it helps it grow. The other one, he's leaving it in the regular soil. This researcher is actually participating in the experiment. So by actively participating, he is manipulating something. He has a control and an experiment group. So we would definitely call this an experiment because he is changing the soil in these ferns. For letter B, to find out whether car accidents are more likely on rainy days, a researcher records the weather conditions during 50 randomly selected accidents for the past year. Okay, so this researcher, all he's doing is he's saying, okay, there was an accident on this day. What was the weather like on this day? Is the experimenter, is he making the weather? No. Is he causing the accidents? Well, good grief, I would hope not. But what he is doing is he is simply observing, hey, there was an accident today, and it was sunny. Check, check. He is not manipulating anything. He's not an active participant in this study. So we would call that an observational study. All right, for letter C, a scientist measures the height of 20 birds' nests and counts the number of eggs to see if there is a relationship. So what we have to do, we have to ask ourselves, is this scientist actively manipulating something? Is he actively changing something in this study? So if he looks up in the tree and he says, hey, there's a bird's nest, and he measures the height of that bird's nest, and he looks in and he counts the number of eggs, is he actually changing the height of the nest? No. Is he putting eggs in that nest? No. So all he's doing is he is seeing that there is a bird nest and he is counting the eggs that are in that nest. So we would say that is an observational study. All right, the next one. The study described in the report is a randomized comparative experiment. Describe the treatment group, and the control group. So we've got to see what are they actually doing to these groups, and then how are they splitting the population. Okay, so here's what we've got. We've got 100 arthritis sufferers reporting the severity of their symptoms daily for 1 month. 50 of these arthritis sufferers were given Epsom salt to bathe in at least every other day. At the end of the month, 30% of the subjects who used Epsom salt reported a decrease in severity of their symptoms, compared to 5% in the other group. Okay, so the treatment that's actually being given to these arthritis patients is, some of them are randomly chosen to bathe in Epsom salt. Okay, the treatment group are the ones that were chosen. The control group are the arthritis sufferers who continued to report their symptoms, but they didn't take the Epsom salt bath. And that was they just saw a 5% decrease in their severity. That might be from like natural health progression, or they may have thought, hey, this bubble bath I'm taking is really helping me. I don't know, but it didn't have Epsom salt in it. So that was not what made them feel better. All right, let's see if we can find the treatment group, and the control group one more time. To test the redesign of its website, an online bookseller assembled 96 users of the site and randomly divided them into two groups. One group used the new website to make an online purchase, and one group used the old website to do the same transaction. Users of the new site were able to complete the purchase 22% faster. Okay? So, what was the treatment that was given to the people that are using the website? Well, this researcher really just took this group of 96 people, split it down the middle, randomly dividing them into two groups. The treatment group actually gets to use the new website to make their online purchase. The control group uses the same site that they've been used to using. Nothing's changing for the control group. It's normal. Treatment group got to use the new one, and it was the treatment group that reported that it went 22% faster. Okay. Explain whether the research topic is best addressed through an experiment or an observational study. Okay. Does using tanning beds at least twice a month affect the likelihood of developing skin diseases? All right, let's think about this for a minute. We have to think along the lines of ethics, along the lines of right and wrong. Would it be right for a researcher to actively encourage people to participate in something that may cause skin diseases? Probably not. But y'all know as well as I do, there's some folks you can't stop them from going to the tanning bed. So the best way to conduct this research would be to do an observational study. We can't make people get in the tanning bed, but if they choose to, then that's on their own accord. So the best way to conduct this would be to just observe. Do people who have skin diseases, maybe you could survey them and say, hey, do you go to the tanning bed? Do you not go to the tanning bed? Okay, classify each method as a survey, an experiment, or observational study, and explain which one would be the most reliable. Now, guys, y'all participate in surveys all the time. In fact, you participated in one just the other day whenever we collected data about your career interests. Method A. Choose 50 people who have at least one serving of soy a day and 50 who don't, and check their cholesterol levels. All right, so you're looking at 50 people who eat soy and 50 who don't. Are you making anybody eat soy? No. Are you making anybody stop eating soy? No. You're just pulling people who already participate in this on a daily basis. So all you're doing is you're just observing. You are checking their cholesterol levels and writing down your results. You're not making some people do one thing or do another. You're just observing and recording results. So method A, we would call that an observational study. Sorry, just making sure our recording is still working. Okay. Method B, randomly choose 100 people. Ask them how many servings of soy they have a week and ask if their cholesterol levels are high. So you're not measuring their cholesterol levels. All you're doing is taking their word for it. If you are trusting your subjects to just give you verbal confirmation or go on their own judgment, if you're just asking them questions, that would be a survey. So method B is just a survey. Method C, randomly choose 50 people to eat at least one serving of soy a day and 50 people not to, and monitor their cholesterol levels. Okay, so in method C, you're choosing 50 people and you're saying, hey, you're going to eat this soy every day. And 50 people, you're saying, hey, you can't have any soy today. So you are actively participating in this study. You are assigning people a role. So that means that method C would be an experiment because you are actively changing the treatment and control. Okay, for method A, randomly choose 50 people to exercise 3 hours a week and 50 people to participate in another activity and monitor their health. Okay, so you've got 50 people and you tell them you have to exercise 3 hours a week. Then you have 50 other people that are like, okay, you go play ultimate frisbee. You don't give them any time limits or anything. You just tell them go participate in another activity. Then you monitor their health. In method A, you're telling people what to do or how to behave. So in method A, we would call that an experiment. Method B, randomly choose 100 people. Ask them how many hours a week they exercise and ask them how healthy they are. Well, method B, you're not telling them how to exercise. You're not telling them how to live. All you're doing is just asking questions. So if you're just asking questions, then we're going to call that a survey. And then method C, choose 50 people who exercise regularly and 50 who do not, and monitor their health. So you may notice 50 people who exercise regularly. Maybe you just stand outside a gym. Maybe for the 50 people who do not, I don't know, you might go to a library or somewhere where physical activity is not taking place. All you're doing is observing that these people live a particular way and monitoring their health. So all you're doing is an observational study. You're not manipulating anything. You're not changing anything.